Okay, let's keep rolling and bring in a little bit of Kangaroo. I brought in some catenary nodes, which are pretty cool, and I garnered a little bit of support. And I thought, why not use something, while we're going through some pretty basic operators. The ones we're looking at this turn are equality, larger than, similar, and greater than. And I think it's fairly easy to figure out what's going on with equality and similarity. You can affect that, have a difference, a threshold in that. But let's just look at applying the greater than, less than knowledge. Whenever I see those, I think distance. So what I did was I pulled off of, I guess I went online or went in GitHub, found a couple of simple Kangaroo, basic Kangaroo scripts, but that really modified them. I mean, what they started as, if you take a look here, they started as basically building a spring form line with mesh edges on a simple mesh. It wasn't too hard to just create one of those, look to the mesh edges and bring it into a spring form line, then find a vertice component. With that, I took care of all this in the middle. They basically inputted that as force objects, anchor points. Anchor points came from the corners. I think they were anchor points. I have to follow that back to here. Yeah, they were actually defined and put in. So that's enough to get going on that. And what I did was I doubled it up. And how I modified the script is I added a bunch of stuff afterwards just for fun. I added some spheres that are relative to kind of like when you activate this script, the balls change in their diameter. It's very subtle here. It's kind of hard to see because I've changed the numbers, but you can see them kind of pulsate. I thought I'd just throw that in to give a go at playing with some distances, and I thought for sure I'd bring in the equalities or greater than or less than in that, but I actually didn't end up using it there. I chased back the script and I said, okay, let's put it in here. Let's take it as a distance of calling out a pattern of these lines. These lines, where are they? The distance here, the called pattern, these lines, which I have to make visible, if I pull them out of the changes in those, the distance between those and, how did I find the distance? Point A and point B. Oh, I just chose one of the points on the line. So as you change your seed, as I go through here, as I change this seed, it changes the distance in those, and of course it affects my scripts, but I have to rerun it to see what's going on. So I have a really cool ability not to do a basic undulated form. I have some really cool control over this. So it jits and jumps a bit when I do that, but it's basically finding distance varies between all the points and one point within that system. And then I say, okay, is that greater than or less than this? Is it greater than or less than 10? And you'll see the script busts as you go outside of it. It goes red there. This one goes red, I think, there. So there's a point where they both work. I mean, I think around 10, they both function pretty good. Like they accept the distance between the both. It doesn't matter. You can make one not work like this, and then jazz this one up and run the other one, see what happens. You see, you get a little bit of difference in it, and then you can run the script back until the other one doesn't work, and then push that program through. So, anytime there's an issue in it, I like the way that one kind of folds. So you can always reset them, but that's fairly simple. So I thought I'd use the distance greater than or equal to advance what scripts I've been seeing of catenary arches. And then I thought it was fun just in the end to grab these. You can put everything off except for the ones you're selecting. And then you can go in and just, what's nice is you can run two. You can't run both at the same time, but I can activate that one. And that's a pretty cool system of what's happening. And there's another one, plus or minus, a nice reaction tones that's not consistent. And this is where, analog and friction and different simulations can come in. And it's only because I'm starting to play with more data as thinking, okay, how can greater than or less than, which comes out as a Boolean, zeros and ones, be called from a pattern, which is basically what I did, and called each one separately, and I called the force objects, and that's how I affected the script differently. It's not rocket science at all, and it's pretty fun to experiment in. Like I said, I could probably play with the distances a little more when I fudge it and make these balls a little more, seed them differently. That just changes the shapes as they go around. If I change the distance here, I might be able to see some more ballooning action on those. It's pretty subtle to what's happening, so I probably would have to affect a little more of the minuses and pluses. So if I blew them up real big, or if I went real small, I'm not sure what would happen then either. But of course, I'm looking at the one, not the other. So let's just jump in here and grab these two. Actually, let's grab these two and have them affected and just hit play and see how those spheres adjust. Now, it's pretty subtle. Just have to play with the maths. So number, distance, equalities, inequalities, and I leave it up to you to bring in the equality, which is going to be hard to find exactly when it's the same size, and similarity, and try and reflect how that would influence your script. 5-minute script using KANGAROO and using operators. And what was the other program I brought in here? I don't think it was anything, just KANGAROO. And you definitely have to use Weaverbird. So as I click on here, now that's KANGAROO. I used Weaverbird off the bat for mesh. So I'll put in those as the plugins on the script. Hope you enjoyed it.